Go ahead and start that if you want.
All right. So now we have Button Up Derry, and now Ted and Andy, you can start.
All right. Thank you very much. I'm Ted, and I'm going to be presenting tonight along with Andy. We're here courtesy of Plymouth Area Renewable Energy Initiative, and we are going to be doing the New Hampshire Saves Button Up presentation, which I am going to share with you instantaneously and momentarily. Let's see, slideshow from the beginning. How's that look?
Yep, there we go. It looks perfect.
All right. So hopefully you're here tonight to hear about improving the energy efficiency of your home. If you're here for something else, you're in the wrong Zoom meeting. So you're welcome to stay if you want to, but we're here again, courtesy of New Hampshire Saves, which is sponsored by all the different utilities around the state that you can see there: Eversource, Liberty, the Co-op, and Unitil. And let's move on. There's a chat button if you have questions as we move along. Chances are we're probably going to cover whatever it is you wanted to ask, but feel free to put it in there. We might just have to hold off on it till later, or we can play it by ear and answer them as we go through. This is a kind of a brief overview of what we're going to be going through tonight. Start off with some really basic stuff. Hopefully it doesn't bore you too much. Then we get into some more technical stuff, some education in terms of insulation and air sealing, what we call the ABCs. You'll get a little overwhelmed, and then we'll talk about, well, what can you do? How can you get some help with this stuff? And then Andy's going to wrap up at the end with a kind of a review of the different incentive programs and rebates in the New Hampshire Saves program. Oftentimes when we're doing these New Hampshire Saves workshops, in real life and in live in person in a library or in a town hall, I'll ask people, what do you think is the greenest energy? And various people raise their hands, and as you can imagine, there's a couple different answers. There's always solar, and then no, I like wind. Wind is the greenest, and then so other people say hydro, other people say other things, and I kind of have with pleasure say, I think you're all wrong. None of those are the greenest energy. To me, the greenest energy is the energy you're not using at all. And that's really why I got into being a full-time energy auditor, which is my day job. About 15 years ago, after a pretty long career in education, I was thinking about getting into renewable energy, solar or something like that, but that's all production. And there's a downside to any kind of energy production. As good as it gets, as good as it can be, there's always a downside to every type of energy production. And there's a cost to all that. And really, when you look at it, the only argument you can't really make against is, not using energy or reducing your energy. So reducing people's consumption is where I chose to get involved in this field. In part because, here in New England, we use a lot of energy and we spend a lot of money on that energy too. This is a graph that kind of shows you how the typical family in New Hampshire might spend their energy dollars. Again, this varies from household to household, based on how many people are in the household, what their habits are, how big is the house, how old is the house, how energy efficient it is, what are the costs of oil or propane, or are you using natural gas? I mean, there's a lot of different variables in here. But, it's funny, I had a customer the other day from South Carolina, and he was just, shocked at how long we have to heat our homes. He couldn't believe it. 6 months, he said. People in other parts of the country have no idea that, that we heat our homes for 6 months, and a lot of us are stuck with propane or oil. In other parts of the country, they don't even know what that's all about because they have really cheap electricity or natural gas. So we're in a tight spot here. Again, and I got into energy auditing and energy reduction and conservation, specifically in regards to buildings, because if you look at this chart, most of the money in the average energy expenditure goes into space heating, keeping a home or a building warm or cool. So that's really where you can make the biggest effect, I believe. I'm glad there's engineers out there working on more efficient refrigerators and things like that. I'm not an engineer, so I couldn't do that anyway. But still, that's only 7% of the pie here, right? So as good as they make refrigerators, that's not really going to be as effective as doing things in that red area. So one of the first things you can do, everyone gets an electric bill every month. You might get it electronically, you might get it in the mail still. Instead of just grumbling and writing the check and paying it, look at it a little bit harder, because there are some other pieces of information in there that you might find helpful. they'll give you some charts here that shows you how things are going for you, like month to month, season to season, what your average is. It's the same theory is happening now with cars, where they'll tell you what kind of gas mileage you're getting in real time as you're driving down the road, because the theory being, like, if you might think about it a little bit more. So that's what some of these, this information that comes from your utility is all about. When it comes to the things in your homes, that are using the most electricity, for the most part, most homes, it's the lighting, the electric water heater, if you have electric water heater, and refrigerators and freezers. Those are kind of like the top 3 users that you can really have some type of an effect on. Yes, dryers, entertainment centers, all those things, they all use energy, but those aren't quite as primary as some of these other ones here. Again, this is going to vary a lot from house to house. Some people would not use anywhere near this much electricity for lighting. Other people might use quite a bit more. If you want to dig a little bit deeper, you can go to the library. I think Derry probably still has this. I know for a few years ago, every public library in New Hampshire had one of these. It's called a kilowatt meter. And basically it plugs in the wall, and you can take anything you have in your house, whether it's a light or a TV or entertainment center, plug it in there. And using this device and using a little math, you can figure out exactly how much this thing is costing you, per week or per month or per year to have on. If you want to get a little bit more in depth, you can actually get a whole house electric meter. This screenshot on the right is actually from the one that's called Sense. It's one of the bigger companies out there. They're about $200, $250. They actually do have a wire too that goes into your electric box. So you need to be pretty handy with electricity and comfortable working with that, or have an electrician do it for you. But these are neat because it'll actually monitor your whole entire house in real time, and it can actually sense when it feels electricity. Oh, what was that? That's a hair dryer. Oh, what was that? That was the garage door. Oh, now the electric water heater came on. Oh, someone's watching TV. So you can actually be like in your office, and you can look at your phone and you can see what's on and who's using what and how much it's being used. So it's kind of neat. You can spy on your kids and stuff. But this is really handy too, because you can track down some things that are kind of hard to figure out. I have some customers that, they've gotten a Energy Star refrigerator, they've got all LED lights, but their bill is still really high. Their consumption is really high, I should say. Everyone's complaining about the bill because the rate is going up, but sometimes if your consumption is higher than you think it should be, sometimes a whole house meter like this can really help figure out, like maybe it's your well pump or something is working too hard, or some other kind of fault in your electrical system. If there's a local energy committee there, we're always recommending that maybe the energy committees in some towns, buy one of these things, and then they could sort of, pass it around from person to person. It could be in one person's house for a month and then go to another person's house for a month. It sounds really stupid, and it's kind of maybe doesn't need to be in here, but shut things off when you're not using them. I got paid some money today to go to someone's house and do an energy audit for a couple hours. And while I was there, there was a TV on in one room and there was nobody in that room. The person was out in the backyard gardening or something. And then I went into the other room and there were a bunch of lights on. I went downstairs and the entertainment center was still on. There was a computer on in another room, just waiting for someone to come in and use the computer, I guess. So I think a lot of times we've all gotten into the habit of leaving things on. So there's some behavioral changes that can happen that can affect your electric bill too. There are more and more things in people's homes these days that actually are using electricity, even though you hit the off button. So off to me means off, but sometimes it doesn't actually mean off. There are some things, we call them vampire loads or phantom loads or energy drips, because they're always pulling some power, even though you don't think they are. And this would be anything with like a charger involved in it, anything that's got a clock or a light, anything with a remote control, right? Like when I was a kid, you had to turn the TV on and then you would go get your snack. And by the time you came back, it would be warmed up and you could watch it. Well, now there's a resistor in there that's always using power all day long when no one's home, just so that when you come home and sit down and hit the remote control, it comes on instantaneously. Things with lights, DVR boxes, things like that, they're all using a little bit of power. And each one's only a little bit, but they do add up. This was a couple examples here off the internet. I pulled the Apple TV there. The second one I thought was the interesting one, because the first generation of those, when they made those, when people were watching it, it was using 21 watts of electricity. And then when they hit the off button and went to bed, and they assumed it went down to 0, it actually only went down to 17. It was almost using as much power off as it was when it was on. So if you add up, the 23 hours a day you're not watching the TV, times 17, right? That comes out to be something pretty significant. One great way of controlling these phantom loads is to get a power strip like this, a smart power strip. That way you can plug things in individually, and then you can turn them off, and they'll actually turn them off, and it'll cut the power completely. You can get these from the New Hampshire Saves catalog or other different places. I actually have one in my house that is has a remote control that I have mounted on the stairway up the stairs. So right before bed, I go walk up the stairs and I can hit the button and it'll shut everything off. And then when I come down in the morning, hit the button and things come back on again. Another thing you can do is turn your water down. This is, if you have electric hot water. This picture is actually kind of funny because it's a gas water heater. So turning that down is not going to save any electricity. It will save some gas, but a lot of homes that I'm in, people have water coming out of their tap that is, dangerously high and exceedingly high in terms of, an energy waste. So really 120 degrees at the tap is all you need. We're not going to tell you to turn your dehumidifier off, because if you have one and you're using it, there's probably a reason, and that's a good reason. So you should keep it running, but you should make sure you have a good one and make sure you're using it, appropriately with the right setting. This shirt here is probably 20 years old. It's never been washed in hot water in 20 years. It's always been washed in cold water. If it got really, really dirty or something, I might wash it in hot water, but it never has. So hot water is a little bit overrated, I believe, in terms of washing. And of course, when you're done washing, you can use a solar clothes dryer, which is a clothesline. There are some places, condo associations I've heard that are trying to pass rules that you can't do that kind of thing. But I think I've never heard of a place in New Hampshire where you can't put out your own clothesline and take advantage of the sun and dry your clothes that way. The lighting has really come a long, long ways, just even in the last 10 or 12 years that I've been involved in the industry. When I first started, we were putting in, the CFLs, the swirlies with the mercury in them. They blinked. They took forever to warm up. People hated them. LEDs have kind of solved all those problems. They come on instantaneously. They don't blink. They have them for chandeliers. They have them for recessed lights. They have them for three-way ones, low, medium, high, for reading lights. Pretty much any application you can think of, you can get an LED for. Sometimes I'll be in a home and I'll be replacing, say, 8 lights in a kitchen and putting in LEDs. All 8 of those LEDs combined don't even use the electricity that one of the old bulbs was using before. They really are amazing. You can get, like I said, you can get them for almost anything. The only thing I would caution you is, you might be attracted to the ones in the store that say daylight, because everybody loves daylight, right? Like, it sounds like such a wonderful thing. Daylight, if you look at the picture at the bottom that shows the 2 pictures, daylight is actually the one that's on the left. It's kind of a bluish hue. In my experience, most people don't like that. It makes them feel really uncomfortable. Most people want something that approximates like an incandescent bulb or even a candle, which would be warm white or soft white. It's 2700 Kelvin. If you want to get technical about it, you can look for the 27 or 3000 Kelvin label on there, but that's probably going to be the one that you're going to want. So don't be fooled by the misleading daylight label on there. Other really easy things you can do that are inexpensive and will save you energy every time you just go about your daily life. The first thing is a low flow shower head. A lot of times people are afraid there's just going to be a little trickle on their head. I've only had one customer in 10 years ever complain, and she had hair all the way down to her belt in the back. Most people actually say that it feels like there's more water coming out with a low flow shower head. Pipe wrap is really inexpensive, really easy to put on. A child can put it on. We're not going to tell you to go out and ditch all your appliances and go out and get Energy Star ones that are more energy efficient, because that really would not be good for the planet if we all did that. But when your appliances are starting to get near the end of their life, it's starting to do some research. You want to be looking for that Energy Star label, because you want to invest in something that's going to use less energy over time, and not think about just like the initial purchase price. You think about the energy it's going to use over the next 10 years. There's also some really good rebates for a lot of Energy Star appliances. You can even get a rebate now for like a room purifier, but you can get it for a pool pump. You can get it for refrigerators and air conditioners and things like that. They vary from thing to thing. You can go to the New Hampshire Saves website for that, or the Energy Star website, and you can find out a little bit more about those. So the main reason we're here today is to talk about staying warm in your home, right? So like I said, we live in New Hampshire. Hopefully everyone that's on the call has lived through at least one winter yet, so you're not in for a shock this winter. But yeah, 6 months of heating is a lot. When I go to someone's house, they want to save energy. Well, I can't just walk in and say, hey, I know what to do. Just turn your thermostat down, put on an extra pair of socks, wear a hat, wear a scarf, dress like this guy. But nobody wants to live like that. Well, maybe some people do. Most people don't. Most people only want to dress like this outside. And then when they come inside, they want to be comfortable, right? So they want to use less energy, but they still want to be warm and comfortable in their house. So that's where it gets a little tricky. A couple things you can do that are really, again, low level, introductory, basic things. Turn down the heat when you're not in that room, turn down heat when you're not in the house. If you have a programmable thermostat, it'll do it for you, right? So you go to work, it'll shut your heat down, it'll cool it off during the day. And when you can have it so it warms back up, and when you get home, it's nice and warm for you. And then right before you go to bed, it does the same thing, and it'll cool off during the night. A lot of times people say, well, geez, it uses more power, more energy to, doesn't it have to work harder? Like the furnace or the boiler has to work really hard to warm it up when I come home. But yeah, it does have to work hard, but the energy that it uses to do that is actually less energy than it would have taken to keep the house at a consistent temperature all day long or all night long. So it does save energy to do that, for an extended period of time. Obviously, if it's just a half hour or something, it's not going to do much. But another thing you can do is make sure that you're paying attention to the seasons, right? Air conditioners are for the summer, take them out in the winter. Storm windows are for the winter, put them down in the winter. Don't leave them up the way you had them in the summer. And, make sure you latch your windows. Windows are designed to be latched. When you latch them, the weather stripping all compresses and it makes a much tighter seal. So if you don't latch your windows, you're actually going to be losing quite a bit of energy. And with that, I'm going to stop sharing, and Andy is going to take over, and he's going to do the next section talking about some building science topics. So then I'll see you guys at the end of that.
Thanks, Ted. So we do a little switcheroo here a couple of times during the presentation, and just keep in mind that if you've got any questions as we go along, feel free to put them in the chat. And I put an item in the chat that if you're curious about getting a PDF of this presentation, it's a little bit dated version of it, 2021, but pretty similar to this one, is available at the Plymouth Area Renewable Energy Initiative website. And I put the link in the chat for that. So next slide, I'm going to share my screen, and I'm going to get into this next section about keeping your house warm in the wintertime. And let me turn on the slideshow. So just a little bit of building science here. And I think, the kind of way to think about this section is that there's lots of good opportunities to reduce energy use that Ted talked about. But as he mentioned, we still live in a fairly cold climate, and a big chunk of the fuels energy that we use in our homes is really associated with keeping it warm in the wintertime. So really the idea is that you want to keep that heat inside the house as much as possible, kind of the idea of this presentation, button up. And heat moves in 3 different ways. It moves through materials, and that's called conduction. It also moves by air currents, and that's called convection. And then it also moves kind of by a line of sight. So think of sunlight, or standing near a nice warm fire on a cold autumn day. You're feeling via radiation the heat from that fire. We're not going to talk about radiation too much, mainly going to talk about conduction and convection. And going to start with conduction. So not a great idea putting a metal rod into a candle flame. It's going to conduct pretty darn quickly through that metal rod to your fingers, and you're going to not enjoy that. It's really kind of the same concept with any sort of like masonry or stone materials in a home. If you put a cold brick on top of a warm brick, that heat from the warm brick is going to be conducting into that cold brick pretty readily. It'll go through those materials. And that's not the kind of thing you want to have happen with the heat inside your home in the wintertime. So insulation is a poor thermal conductor. That's a good thing. That's what you want to have happen. And there's lots of different materials that can be insulation. Ted and I joke about, maybe we could establish a museum of weird insulation. And that's what this slide's all about. Seaweed up in the top or left as insulation, or rags over on the right, or back around the 1950s, an insulated quote unquote house was about an inch thick of insulation. Now we're talking about 16 inches or something like that up in the attic. So slightly different standards now than then. And insulation is typically measured in R value, and it could be either like R value per inch or R value for kind of the whole item or assembly. So the first 4 items here that I've given you, those are R values per inch. So if you're putting, say, 5.5 inches of cellulose in a wall that's a 2x6 frame wall, that's a pretty good amount of insulation. A window right next to it might only be about R2, R3, or maybe R4 at best. So it's not going to be as good in terms of that lack of conduction or insulation. And it's just because of the way windows are made. They are kind of necessarily thermal weak links when it comes to conduction. And we'll talk a little bit more about that later.
Andy, wow. An attendee, wow, I found the word, don't worry. They had a question. They said, do you have, if you guys have a link to the information on the recent federal legislation that is providing tax credits as incentive for energy saving upgrades?
Yep.
I know you had mentioned potentially talking about at the end of the program, but do you have a link that you could provide or a place to find information? Because
there's a couple good websites that have information. There's even like a little thing where you can put in information about your home and it tells you what sort of credits would be available. So next time Ted is speaking, I'll be glad to put those links into the chat.
Okay, awesome. Carry on.
So we're talking about conduction and kind of that opposite of conduction with insulation, and different materials can be used for insulation. So I was mentioning wood is really not that great of an insulator. As you can see, on a per inch basis, it's about 1/3 the value of typical insulating materials, and even could be less when you compare it to something like spray foam. And then probably about the worst that's out there is concrete and masonry, like bricks as well as stone. For 8 inches, 8-inch thick concrete wall, it's a little bit over R1. So it has a lot of thermal mass, but it does not insulate very well. So there's a lot of poorly insulated basement walls in New Hampshire. And that's as Ted's going to talk about a little bit later, that's certainly an area to be kind of paying attention to in terms of improving your home and energy performance of your home. And then just keep in mind that it's not just the rated R values, it's also the install quality of that insulation. You don't want to have any gaps or things like that in the insulation. It really should be kind of a continuous layer. And kind of a lot of numbers to throw at you here, so I'm not going to go over all these numbers at the top, but I think it's sort of safe to say that there's a lot of homes in New Hampshire that really aren't performing as well as they could. And part of it is they don't have enough insulation, but part of it is the insulation that they do have is not that well installed. So an example here down at the bottom is if you had an attic that was 95% R38, which is a pretty good amount of insulation, 10 or 12 inches of kind of the fluffy stuff, and only 5% R1, where you can kind of see the cracks in the insulation. What would be the average R value of that whole assembly? And I already kind of gave you a hint at what it is. If anybody wants to make a venture, I guess, glad to kind of pause here for a second or two. And I see there was a message about window quilts. We'll talk about that. I think Ted's going to talk about kind of options with windows besides replacement windows and a few slides down the road. So you might think, 95% R38, yeah, maybe it's around R30, maybe R25. It's R13. That 5% of the area that's R1 is having this disproportionate impact on the total R value. And it has to do with physics. I'm not going to explain it tonight, but if somebody's curious at the end of the presentation, I can show you the math behind that. But I think it's safe to say is those gaps, those missing parts of insulation, those can really have a big impact. And so it's kind of like this example, kind of incomplete example of insulation in the middle photo, where you do see wood in addition to, those are bats of kind of off-white beige fiberglass insulation. Fiberglass, the glass in fiberglass isn't insulating, it's the little air pockets that cause it to be insulating. So if that was covered where you wouldn't see that wood, that would be a much better insulating assembly. And I think the photo over on the left is pretty obvious that there's not enough insulation or insufficient. And what you're seeing there also is the unpainted rectangular box is a bath fan that is not vented to outside, which is not a good thing either. And that's also another item there is the white item is a ceiling can light. A lot of those aren't even rated for having insulation in contact with them, let alone being covered by insulation. So that can be a problem as well. And then the example over on the right is kind of unusual, but it does happen where somebody did a pretty darn good job of insulating an attic area. And what you're seeing is on the side of the house, the gable end of the house is a louvered vent to outside. Well, you know, slight problem there. They're basically insulating outside to outside, because all that gable end vent does is bring in lots of cold air in the wintertime. So it's really not doing any, the insulation is not doing any good. So it's important to kind of have the insulation well aligned. It's where energy performance professional can kind of help figure that out, but it's also something with a little bit of learning and kind of understanding building science, you can figure out where the insulation should be going. So here's an example where the builder just didn't quite get it. Looks like a nice house, kind of a modern style house. Take a look at that white duct register that's kind of in the middle of the wall there. There's some exterior windows and then a duct register below that. And see on the inside, you can see where the ducting is going to that register. And then there's a whole row above that that doesn't have insulation. So definitely not a good assembly. And this type of problem is actually more common than you might think, where just areas get missed. There, you know, one way to think about it is the harder it is to get into an area, the more likely it's going to have problems in terms of missing insulation or misaligned or just not enough of it. So I want to move kind of from that whole conduction concept of heat transfer to convection. And I think a good way to start that out is to kind of ask the question to you, heat rises, is that a true or false statement? And I'll give you a little opportunity to kind of ponder that. It's kind of true, but it's also sort of false in the sense that when heat conducts through material, it really doesn't matter what direction. There's no gravity going on with conduction. It basically goes up, down, all around. So it can conduct down through materials, it can conduct sideways, it can conduct upwards. So probably one of the most uncomfortable and poorly performing type houses in New Hampshire is a house that's considered, that is what's called slab on grade, where you have a concrete slab that's at the same level as the soil. That warmth from inside that is absorbed by the concrete conducts out through that soil sideways and makes the house cold and very uncomfortable. And it's also quite hard to fix as well. But you get a little kind of partial credit for saying if heat rises, in the sense that warm air does rise. And so think of, not that you're going to have a hot air balloon inside your house, but in some ways that's kind of how the air in your house is moving. It's going from down low to up high, and it tends to leak out of the higher areas of the house. So a much better graphic is this one here over on the right that shows what's happening, not so much this time of year when temperatures outside and inside are pretty similar, but more when it's cold outside. So when there's a big temperature difference, there tends to be a lot of cold air leaking in through little tiny cracks down low in a house, and a lot of warm air leaking out up high. There are many houses in New Hampshire that are losing more heat from this air leakage than they are from losing heat by lack of insulation. And so it's a very important concept to get a handle on. I like to tell people that it's kind of like you need to have like these two different nodes in your brain. You need to have like the conductive heat loss node, and you counteract that by insulation, and also need to have the air leakage node, and you counteract that by air sealing. The problem is that there's a fair amount of insulation. Anything that's kind of fluffy isn't really doing a very good job typically at countering that air leakage problem. So that's why you can't just say, oh, my house is insulated, we're all set. You have to recognize that there can be ways that there's heat loss escaping through air leakage. And we like to say that air, especially these days, that is expensive air. That's air, warm air in the wintertime that you are paying dearly for, particularly with fuel prices like $4 or $5 a gallon for heating oil. And so you don't want that warm air to heat the outside. You want to keep it inside. And the best way to determine whether you have a problem with that is with a blower door air leakage test. And Ted will be talking about that in a little bit. And just worth mentioning that, when we talk about the stack effect and this convective heat loss, you can also have convective loops that happen inside a house. So like say a wood stove in a room, it's going to cause the air around it to warm up and rise. And so you have kind of this looping effect like you see in the graphic down below. Or I like to say, if you really want to kind of get energy geeky on a cold day, take a piece of tissue and just sort of hang it in different places, like up high and down low in a doorway, at the top of stairs or things like that. Basically, you'll see in many places, particularly if one room's warmer than the other, that there'll be two counteracting currents. One current going, warmer air going one way up high and colder air going the other way down low. It's the same concept, but it's kind of more internal as what's happening with your house overall with outside and air leakage. So this is another graphic that kind of helps show where there's a lot of where air leaks, particularly that warm air leaking high up into the attic. Those are things that you want to control. Same thing with the cold air leaking in down low. It's going to be really hard for you to notice, even on a cold day, that warm air leaking up high. You might be able to find places where cold air is leaking in down low, and it's worth kind of going around on a cold day and just sort of feeling around the edge of the house in the basement. But really, there's more effective ways than just kind of doing that to determine the amount of air leakage. And again, that's a blower door test that we'll talk about in a little bit. And then another way to think about all this is A, B, and C, and that is the priorities for air sealing, or the ranking of air leakage areas is first up high, A, in the attic, and then down low, B, in the basement. And then probably the lowest lowest priority is C, center of the building. So when you hear like these tips saying, well, seal around your windows, they're really not getting at the crux of the matter here. There's things that are kind of more hidden, particularly with the attic and some areas that might be a little hard to access in the basement, that are probably causing a lot more air leakage than around your windows. And so here's just a couple photos of examples of air leakage in the attic. And it's accentuated by kind of a natural effect that a lot of times the air, the fluffy insulation, particularly kind of bright colored fiberglass insulation that you're seeing here, either blown or in bats, is gotten stained by dust that comes up through those cracks and holes. And we're really only talking about, things like little 1/8 inch crack can make a big difference. What we're talking about is pressure differences that is kind of the driving force with air leakage. And so it is important to see all these little holes and cracks. And that can be done as a do-it-yourself activity. It's really important to do that before doing any additional insulation. And Ted's going to be talking more about kind of air sealing and approaches with that. And then professionals who do this all the time have the right tools and materials to kind of go after that, and the blower doors and things like that to analyze it as well. So here's a pegboard attic hatch, and let's just say that it has 16 inches of fiberglass on top of it. Is that a good assembly? Yes or no? And if we had more time, we'd do a little poll and see what people said and things like that. but I'm just going to kind of keep on going here. That is not a very good assembly. That's certainly plenty of insulation, but the problem is that all those holes in the pegboard material, the pegboard hatch, are causing a tremendous amount of air leakage. So that when I see something like that, Ted or I see something like that, we're like, oh my goodness, your house is a basket case. And unfortunately, there's a lot of houses, it might not be quite as obvious as this, but there's a lot of houses that have plenty of sources of air leakage. And another thing just to keep in mind is that it's not just the warm air that's leaking out, it's also warm air and water vapor or humidity that's associated with that air. And if it's in an extreme situation, it can condense on the underside of an attic. And so that's what you're seeing with all the mold spots. That is not from a leaky roof. That is from condensation of water vapor, because cold air doesn't hold as much water vapor as warm air. So just keep in mind that there can also be these kind of other effects associated with air leakage as well. So that was up in the attic. Now we go down to the next priority, B, in the basement. And just kind of quickly, there's a number of areas, any place where you can kind of feel that cold air on a cold winter day, or if you can see daylight, to go after those. You can see a schematic in the lower left of it's what we call the rim joist or sill plate area. It's essentially where the foundation and the frame part of the house meet, and that can be a weak link in terms of air leakage. And hopefully you know by now that just putting a piece of fiberglass in that what we call joist cavity is not going to solve the problem. There's still going to be air leaking through that fiberglass. You have to use a material that is going to seal as well as insulate. And so again, it's those two different nodes in your head, the insulation node as well as the air sealing node. Very important to be kind of going after both of those. And Ted will be talking about solutions along those lines a bit more. I'm kind of giving you all the problems, but Ted will be helping you with the solutions. So the center of the house, not as many opportunities, but there are some. So things like a chimney flue, if you don't have a good damper for those, if it doesn't close very tightly, then it's just the same sort of concept as having an open window in a house. That's a lot of potential warm air, expensive air that can be leaking out of that fireplace. So very important to seal that up, and there's a variety of ways. Some exterior doors, particularly if you can see daylight around them, are going to be a source of air leakage. And as I mentioned before, most windows really don't leak that much air. It's really a conductive problem with windows, is that if you sit next to a window on a really cold day, you might feel kind of this draftiness, but the draftiness is from air cooling from that lack of insulating capability of the window, and not from the fact that it's leaking air from outside in. So just keep in mind that, you might be thinking, oh gosh, houses need to breathe. I really don't want to seal up my house, so I'm running out of oxygen, or things are getting really stale in the house or something like that. It's really not that much of a problem for most homes, in that a lot of homes in New Hampshire are on the order of 2 to 4 times more leaky than they should be in terms of air leakage. And one of the problems with that is that all that cold air that's coming in the wintertime is very, very dry air, because cold air can't hold much water vapor. And so you're really making your house nosebleed dry in the wintertime from all that air leakage. So a great benefit of air sealing is kind of keeping that humidity in kind of more stable, as well as just the comfort of not having a drafty house. And again, this can be measured exactly how much air leakage is in a house, and how it compares to national standards can be measured with a blower door test. So an adage that we like to say is seal tight and ventilate right. And by ventilate right, we mean mechanical ventilation for fresh air. And that can be done in a variety of different ways. But the whole idea is that, rather than kind of a loosey-goosey house needs to breathe, and, who knows how drafty a house is, having it measured with a blower door and then providing a measured amount of fresh air through a mechanical ventilation approach. And there's even kind of fairly sophisticated approach over on the right is a heat recovery ventilator where the stale air that's going to outside preheats the fresh air, cold air that's coming in the wintertime. And all sorts of other kind of control strategies that I'm not going to go into depth here, but suffice it to say that it's very doable to meter that amount of fresh air and have a very well air sealed house. And then for anything in terms of either fresh air or say a bath fan or kitchen fan, very important that those are insulated ducts, and those insulated ducts go all the way to outside, that they don't terminate in a bathroom. I mean, sorry, in an attic or something like that. And actually what you're seeing might be a little hard to notice, but there's staining on the underside of this roof in the upper left photo. And that has to do with actually the moisture that's getting kind of loaded into the attic from that bath fan. Not a good thing at all. And what you're seeing in the lower right with the green arrow is actually a chunk of ice from condensation from an uninsulated bathroom vent duct. Not a good thing either. And certainly not a very functional bathroom vent duct there. So, we've talked a little bit about moisture. I'm not going to go into detail here, but I think it's important to recognize that a good energy performance professional is going to pay attention to moisture, particularly moisture in its water vapor form, humidity. So even things like a dirt basement or crawl space can load a house with a lot of moisture. And there's strategies to go after that, putting a heavy duty plastic down. Wet basements are a little bit more challenging, but it is important to address those items so you don't have a problem with house durability or mold or anything like that. So we're gonna switch back over to Ted here, and I will put some links in about the Inflation Reduction Act. And let me stop my screen share. And we've got another kind of quiz here for you with the next slide.
All right, thanks, Andy. Sharing my screen now. All right, so if you paid attention to Andy, hopefully by now you know that you can sort of sleuth this house out and figure out why this house has such a big ice dam problem. I mean, you can get an ice dam on like a shed or a chicken coop in your backyard that has no heat, but in a building that has heat, usually it's because of the heat in the house getting where it's not supposed to get to and then causing the snow to melt, and the snow gets to the edge of the roof where it's cold, the way the roof is supposed to be. Nothing wrong with the roof there. Then it refreezes and starts backing up. It can back up onto the shingles. I've been in multi-million-dollar homes that have sheetrock falling in because the water is backed up onto the shingles and is coming in the house. I've seen cars crushed by these big icicles when they fall off of roofs from high up. So it can be really dangerous and really damaging, and it's just in most cases it's a sign of a lot of heat loss. So there could be two things going on here. It could be one or the other or both. One could be just a lack of insulation. It might only be R3 or R5 or R10 up there. But it's possible that this attic might actually be insulated to R50 or 60, and it still might have an ice dam problem like that. Because if there are a bunch of places where the air in the house can leak up through that insulation and get into the attic, then that's going to cause the snow to melt. And like I said, Andy mentioned, in most houses, it's a combination of both. I haven't been in a house, well, I don't think ever, where I was able to say it's got enough insulation and it's not leaking. They all leak and they all need more insulation pretty much. I was in a brand new house in Durham just last week, and that house needed some more insulation, believe it or not. $800,000 house, brand new. And it had the leaks in it, some really, really big ones. So you can only imagine, what an older house has, especially in a state like New Hampshire, where we're not really that good at enforcing building codes, and you don't even need to be a licensed contractor to build a house. So you kind of get what you get. Now, there are a couple of things in these attics that are potentially making heat, which could potentially melt snow. You can see there's two big brick chimneys up there. The one on the left, if you look carefully, has some snow on it. So I got a feeling maybe that's not even an active chimney, but the one on the right, that might be an active chimney. So there's this big, masonry thing up there that's warm. Not a whole lot you can do about that, but you can do a lot, with the things that you can control. We can't control like the amount of sunlight hitting the roof or the color of the roof necessarily, because that's going to melt some snow too. But, in terms of heat loss from the inside, if we're going to do something to this home to reduce the energy bills, it's going to make the house more comfortable. It should also make an ice dam situation, better, if not solve it completely. Hopefully this isn't someone's house that's on the call today. I apologize if it is. Actually, this is from Vermont, but there was a time I did a button up a few years ago at Portsmouth, and I showed a picture, and there was someone in the audience that said, "Hey, that's my house." I recognized her. She was someone I'd done an audit for a few years beforehand. She was there with a friend of hers. And hopefully you know enough now that this is definitely, well, technically it's not false advertising, I suppose. I took this at a hardware store down in Southwest New Hampshire. If you put roof mount tablets up on your roof, yes, it will get rid of your ice dam. So it's not false advertising. However, not very safe, also not very easy, not very cheap either. And the worst part about it is once it does its thing, it melts the snow, and all the snow melts off, and then a week later we get our next snowstorm. They roll through like every week. You're going to have another ice dam. This is not a permanent long-term solution. This is a one-time thing. If you're lucky, you might get rid of one ice dam, and that's it. So I always kind of chuckle when I see these advertisements, people fall for this, and they're really kind of barking up the wrong tree, because they're not going after the real. They're kind of putting a Band-Aid on a broken leg. They're really not going after the culprit here, the main culprit. Again, remember the ABCs, going back to what Andy said, the attic, basement, center. And it's really important that you tackle the air sealing first, because here's a picture of a gentleman, blowing lots of really good cellulose to get his attic up to R50. That's great. But hopefully he did the air sealing first, because it's really hard to find all those spots that need to be sealed afterwards, first of all. And if you forget about doing that or don't do it, then you're really kind of only getting at the conductive heat loss. You're not attacking the convective heat loss. So air sealing is really important to go first. You want to start in the attic. That's the most important part, as Andy said. This left-hand picture shows, sealing up a chimney chase around a chimney, because by fire code, you shouldn't have anything combustible right up against that chimney. Usually when I'm in an attic, like I could take my phone if I wanted to and drop it from the attic, and it would go all the way down to the basement sometimes, even in a 2-story home. And that means any air getting into any of the walls on either story through the sockets and the light switches and the trim and everything else, will just get into the walls, and the electricians have run holes through everything. So it'll get into the space between the first and second floor, and then it'll go sideways. It'll get to this chase, and it'll go right up into the attic and out. So that should be sealed up. You can't just like stuff it with fiberglass. You can't put foam in there. This is done by professionals with metal and fire caulk and things like that. So you have to be a little bit careful when you're going after some of these things. You can go around and do each individual place. Like Andy showed you the stained fiberglass. You can go up there and look for that, and you can go after each one individually. This right-hand picture is actually an interesting one, because there were so many holes, so many leaks in this attic, and the insulation was so trashed that the homeowner decided just to pull it all out, which basically meant it was like almost like a new construction. And we were able to come in and put like a sort of a monolithic layer of spray foam over the whole thing, like just 2 or 3 inches, because it's expensive stuff. We didn't get the full R value with that. The R value is going to come after this when we add like another foot of cellulose. You can see how tall it's going to be, because you can see the wooden barrier in the background there against the chimney. So this is sort of like after the air sealing has been done. It was just decided that it was easier just to do a whole big long sheet of this spray foam, rather than doing it piece strategically each one. A lot of people have pull down stairs for their attics, and usually you can just look right up into the attic. Sometimes they have one of those skimpy little tent things you can buy. They're kind of useless. There's no R value to them. They don't stop any air. So this is a picture of how it should be done. This is a professional installation. If you're really handy at home and good with tools and construction, you could probably pull something like this off. But this is exterior weather stripping that you would find like on your front door around this attic hatch. It's wood, so it's not going to bend. Behind that, there's actually 6 inches of rigid foam board, similar to the little hatch that you can see in the top left picture there. That shows an attic where somebody was sort of adamant that they needed to maintain storage up there. So we built a little wooden wall so that they could store stuff on one side, and then the other side had, the full cellulose. And then you can see the hatch has, lots of insulation there. Bottom picture shows sort of like a knee wall space where the slope was spray foamed, and then the little sort of 1 foot tall wall, and even underneath those floorboards is insulated. If you look carefully, you can see a round hole or plug there where the cellulose machine got put in there, and they filled that cavity up, just the outer foot or two, and then put the plug in there. So all sorts of different creative ways of going about these. Each house is a little bit different in terms of how you're going to, attack the situation. Capes are kind of interesting. Knee walls, I haven't met a knee wall that didn't need work yet. Every single house that has a knee wall or knee wall space, they always need work, even brand new houses. It's just not a part of the sort of standard building practice yet to do these right. Left picture shows a situation where the homeowner was going to actually finish this space up there. So you can see it was spray foamed, and it was actually shaved back nice and flush along the rafters so that could be drywalled. And then this right-hand picture is obviously a much smaller knee wall space in the back, sort of bottom, and that was done with rigid foam board. So different approaches there. Again, after the A comes the B, the basement. Here's a before and after picture of a home, right? So if you're in the basement, like you can see the daylight coming in around that bulkhead on the left-hand picture, the before picture, because there's no doorway in there. That's a sign, right? If you can see daylight, that's a sign. So the bulkhead doors, there's nothing wrong with the bulkhead door. They're not designed to keep out air. They're just designed to keep out water and people and raccoons, basically. So in this situation, it took a little bit of work, but we were able to build like a custom door in there. And that's not pretty, but it works really well. It's really super insulated. It's got weather stripping. You can see it's foamed around the edges because it was kind of a rough opening. But that's really the way it should be. And I'm actually in some homes that are only 10 years old, and they don't have any door like that. They look just like that. You can see daylight coming in. It's kind of astounding. The walls in a basement are really where you want to insulate in almost every case, right? You want to have a good thermal barrier on all 6 sides, the 4 sides, the top and the bottom. But the bottom usually doesn't mean the under the floor part, because in most people's homes, you got a furnace down there or a boiler, laundry machine, wells, things like that, water conditioners. You don't want to be putting that stuff on that cold side of the insulation. That would be bad. So the walls are the better place to get the insulation. If you have a nice smooth wall, like the top left picture, you could do it with rigid foam board. You kind of have to be careful that you get it sealed really well to the wall, because if you don't and air gets back there, then you have to start getting condensation and mold and things like that. So yeah, basement walls, it's kind of an area where you might want to think about getting some professional guidance on this, because there are several ways of messing it up and doing it wrong, and then you'll kind of regret it. If you have like a brick wall or a rubble, granite foundation, you would be forced to use spray foam, because that'll get in all the nooks and crannies and go up and down and in and out where it needs to. So that's the right-hand picture there. That typically needs to be covered with an intumescent paint to meet the fire code as an ignition barrier. Bottom left picture, is sort of a walkout basement that the person decided they're going to finish it. So they studded it out first, and then the spray foamers came in and spray foamed sort of between the studs and did it that way. You can see that's a little bit of a different color, because that spray foam doesn't need to be painted, because it's going to get covered with sheetrock. Yeah, so basements can be tricky. And as Andy mentioned, if you have a water issue in your basement, you really want to get that taken care of first. Whether it's a dehumidifier, sump pump, something like that, gutters on the outside of your house, all sorts of different things you can do to, reduce water intrusion into your basement. Again, the center of the house, counterintuitively, is the least important place to air seal. It's much better to air seal and insulate your attic and your basement really, really well. And the center is really not that important. This is a situation where the person had like a chimney going up through a closet. So that was all done with fire caulk and metal around that. There's some really good weather stripping out there for doors. You can do that on your doors. They have chimney balloons. If you have an old chimney you don't use anymore, flue blockers, things like that. Sometimes there's some caulking you can do in the center. But again, you shouldn't be touching anything in the center of your house until you've gone up in the attic and done that, or had someone done it, and the basement. Otherwise, it's really not going to be very effective. If your walls are empty, which there are many people are living in houses with empty walls still, as long as your attic and your basement is really good, that's actually not the worst situation to be in. But if your walls are empty, that's something you definitely need to get some help on, because you might think you could do it with like one of those cellulose machines you might get at the big box stores. They give them to you for free, actually, for a couple of days if you're going to buy a bunch of bags of cellulose. But those are really only designed to do what you saw in that first picture, which was stand there and blow it out loosely in your attic. And that's fine for an attic, but in a wall, that's not the way you want to do it. It's called dense pack insulation. And really the only machinery that can do that is on like a professional installer's truck. So it needs to be done right. It also, as you can tell, involves quite a bit of work. You got to pull off siding, you got to drill holes, you got to feed the hose up. There's really kind of an art and a science to it. It's a really pretty specific technique to doing this and doing it right. So if you have empty walls, I would definitely encourage you to get some guidance on that rather than trying to do that one yourself. If you have a forced hot air system, you have ducts, and if you have ducts, a lot of times they're in attics. Many times they're not insulated, many times they're not sealed even. So it's a high pressure system, and the air inside there is connected to your house. Even when the system's not running, it's connected to your house. When the system is running, it's really expensive air. It's either really hot or really cold. If you have air conditioning, it's trying to get to the rooms. A lot of that is leaking out through the little cracks. That's an energy waste, right? As Andy mentioned, not only is it an energy waste, but the air coming out of those cracks, well, it might not feel very humid to you in the house, but if it gets up in the attic where it's cool, then it's going to start causing condensation and mold and things. So sealing your ducts is really, really important. You don't want to use duct tape. I know that kind of sounds funny. I don't know why they call duct tape, but it's not really effective on ducts. So don't use duct tape on ducts. You want to use mastic, which is this goopy stuff here. You can also use like a foil tape. That's another way of doing it. That's a little bit not quite as good as mastic, but it'll work. And then, pay attention to the insulation around those ducts, because oftentimes those are put in places like really, cold attics, and they're not insulated. So it's like, you might have a great insulation layer on the floor of your attic, but if you got all this ductwork up there that's either bare or only has a tiny little bit of insulation, you have some issues. Hopefully there's no window salesman on the call tonight that I'm going to offend, but windows are terrible. I wish we could just get rid of them completely. Some of these new LCD screens are so good. I think you could just put a video camera on the outside of your house and then put a screen on your wall and show you what the window would be looking at if you had a window. I say that kind of jokingly, but windows are always going to be the worst part of your house. Even if you spent top money and got like a triple pane argon filled window from Canada, it's still going to be the worst part of your house. So it's going to cost you like, say, $1,000 just to improve like a little, 9 square foot area, a little bit, and it's still the worst part of your house. I mean, there's no, a mathematical system that makes that cost effective at all. There are some things you can do with windows though that can improve them at a fraction of the cost, right? So if you have an old single pane window, you could get an interior storm or an exterior storm, but there's companies now that do really good interior storms, which is really popular with people who have funky windows or they're in a historic district, and that's not something that they're allowed to do. If you Google search, there's a couple local companies that are doing really good jobs with interior storm windows. You can get really good cellular shades. You can get thermal curtains, window quilts. Someone mentioned there's all sorts of different things you can do to sort of address windows to improve them and not break the bank by spending all this money. I lived in a house actually for a while that had triple pane argon filled windows, and when you sat in front of that window and like read a book, it was still cold in front of the window. So for all that money, still issues. Some people are like, well, yeah, they leak like crazy. There's cold air coming in. I'm like, okay, well, again, think about what Andy said. If there's cold air coming in, where's it going? There's only so much air that can fit inside every house. It's a fixed volume. So if cold air is coming in, that means somewhere else warm air is going out. And when warm air goes out, well, it has to get replaced by something. So that's actually what's causing the cold air to get pulled in around old windows. So if you have old leaky windows, turn the other way, find your attic, go up in your attic and work in your attic. And that's actually the most effective way of reducing the leakage of your window. So that's my spiel on windows. Windows are also not covered by the rebate program, because the rebate program that Andy's going to talk about, one of their main jobs is to only spend the money on really cost-effective measures. That's why they don't do windows, because windows are not really in a cost-effective measure. Now, if your window is, if the seal is shot, it's all fogged up and you can't see out of it, it's cracked, it won't it's unsafe and it won't shut right. Like that's a good reason to replace the window. But to replace your windows and say it's for energy efficiency is kind of a bunch of hogwash, if you ask me. And if you ask anyone who has studied this stuff. But you're probably feeling a little overwhelmed like this little dude is here, because we went over a lot of stuff and I talk pretty fast, and so does Andy. You might be thinking about getting some help, and there is help out there. There are people that do energy audits, and they're in what's called the home performance professional industry. And they don't just come to your attic and like measure it and say, oh, you need this much insulation. They never just go into your attic and come out. They spend a couple hours there. They go into the crawl spaces, the basements, the attics, the walls. They use all sorts of different tools. They're going to do combustion tests on your HVAC equipment, like your water heater, your boiler, your furnace, to make sure that's running safely and effectively or efficiently. And at the very end, you're going to get a written report. It's going to tell you, here's what we found in your house. Here's the options. Here's how you could fix it. Here's how much it's going to cost you. And in most situations, they'll say, here's how much it's going to save you too. So you can kind of get a better feel for, where to go from there. Because most people know that their house needs work, right? Like, it's just a question of like, well, what work does it need? What's the best thing to do now? What's the most cost-effective thing to do? I don't want to mess it up. And that's where an energy audit, can come in to play. I would caution you to do your homework. Find someone who is certified. Doesn't have to be BPI, but BPI is one of the national leaders in training people. Andy and I both are BPI trained auditors. If Andy and I wanted to cut hair in New Hampshire, we'd actually have to get a license to do that. But we don't need to get a license to be an energy auditor in New Hampshire, because New Hampshire just doesn't do that. You also don't need to get a license to install spray foam or to do insulation. You don't need any kind of license or certification or anything like that. So it's important that you do your homework and get someone who's trained and has experience and knows some of the tools of the trade there. If you're looking for a list of people, you can go to REPA, which is a nonprofit group. The website is there, and there are people there that can, guide you down the road and you can trust. You can also call NHSaves, even if you don't end up not getting into the rebate program that Andy's going to talk about. You produce your fuel usage and your square footage of your house, and they say, well, your house isn't really that bad, so we're not going to give you we're not going to let you into the program. If that happens, you can still ask, well, who are some of the people that you guys work with? Because NHSaves program only works with a qualified list of sort of vetted contractors. So that's another place you can go to get some trusted help. One of the things that you might get if you get an energy audit is a blower door test. That's a big fan that goes in the doorway. If you have asbestos pipe wrap or something like that, there's a couple of things that sometimes exist that make it so that you can't do this test. But in most cases, it can be done, and it's a really, really cool test. In fact, every new house in New Hampshire is supposed to be getting one of these tests. I can tell you for sure that that's not happening. There are some towns that are doing it. A lot of towns that weren't doing it are now doing it. But it's a learning process, so it's New Hampshire. There are some towns that don't even have building inspectors, or if they do, they don't really know what they should be enforcing. But we do these routinely, in existing homes to find out, how leaky is this house? We all know the house is leaky. That's a no-brainer. It's just how leaky is it? How much is it costing? Is it a really severe problem, right? You can also use the blower door to find out where it's leaking, not just how much it's leaking. Andy mentioned, what happens if you get your house too tight and sealed up, right? First of all, that's really, really unusual. It doesn't really happen, but the only way to know if it's getting to that point is to get a blower door test done. So the reading on the blower door test will tell you if you're getting down to that point. You can also use a blower door test. Typically, we use them before a project and after a project to sort of confirm that we've actually gotten the reduction that we wanted to. Really neat test. It's one of my favorite tools that I have. Oftentimes, you'll use a blower door test with a infrared camera. Infrared cameras sound really cool, and people think that they see through walls and stuff like that. They really don't. They're actually really, really basic. All they do is like tell you the temperature of the thing you're looking at. That's all it does. And then it's up to the person who is looking at the picture or the image to figure out, well, what's going on here, right? So this picture here that you see of the this sort of quaint HOME sign on this wall, the infrared camera is telling us there's something going on with that wall because it's not all the same temperature. It's not all the same color. Each color is a different temperature. So there's like the left side, the HO is different than the ME. And there's like a line going across, like what's going on there, right? This wasn't even an exterior wall. Believe it or not, that was an interior wall. There's a laundry room on the other side of that. So The infrared camera can be interesting and helpful to sort of figure out some of these weird issues that you would never have known otherwise, just by looking at that. Bottom left picture, you can see there's a green arrow there pointing to sort of like a triangular little area. I took that picture a few years ago up in Lebanon. This house was actually built by an architect. When I walked in the house and the homeowner said that, I knew he wasn't the architect. He was the second homeowner. When he said that, like, I knew I was in for a treat. And the bathroom right below that had frozen pipes 2 years in a row, because that whole triangular area is freezing cold. That's why it's so purpley, because purple is cold in the wintertime here. So yeah, architects and frozen pipes. You don't think those things go together, but they do. They don't see ghosts and things either. But another good reason to get an energy audit is because they're going to do combustion safety testing of your water heater, your furnace, your boiler, things like that. They're going to be checking for things like carbon monoxide, because there are situations where there is backdrafting or other issues going on with these systems, and there's carbon monoxide poisoning. I don't have time right now, but if I wanted to, I could take my phone out, go to Google News, and type in carbon monoxide deaths. You can try this when we're done if you want. I guarantee you, if you type in carbon monoxide deaths into Google News, somebody died this week somewhere in the country, probably multiple people. It's not even winter yet, and people have died. It might be Houston, it might be San Francisco, it might be Burlington, who knows? Water heaters, furnaces, wood stoves, all sorts of different things. Carbon monoxide is deadly. It can hurt you, it can kill you. You don't know it's there because you can't smell it, you can't taste it, you can't see it. There really is no way of knowing it's there unless you test for it. So make sure you have a CO detector. Those are really inexpensive and they're really important to have. We recommend at least one in every house that has a combustion device. We recommend one per floor basically is a good idea too, because it's not something you want to fool around with. Heating systems, it's really important to get those tuned up every year. I can't tell you how many times I go into a house and I say, oh, so that boiler looks kind of old. When's the last time that was? Oh, no one's looked at that thing in 20 years. It works fine. It's like, no, it doesn't. It's not the kind of thing you can just leave just because it works, right? Like it's like a car. Like there's maintenance that has to be done on these things. Filters have to be replaced. It has to be tuned up. It doesn't matter if it's oil or gas or whatever. Like get them tuned up, making sure they're working safely and efficiently. Andy will talk a little bit about some rebates that are available for, getting a higher efficiency system. Chances are you're better off getting your attic and your basement air sealed and insulated first before you do that. But in certain situations, in some places, a new heating system is the best option. Or sometimes it's on its last legs. That's the time to start looking for something more efficient. Two quick examples of some energy audits that I was on. The blower door basically sucks all the air out of the house, right? So it's sucking air in through gaps and cracks and holes. You close all the windows and doors, and then whatever's going through the fan is coming through the gaps and cracks and holes. Well, I was in Portsmouth and I cranked up the blower door, and it sounds like a loud vacuum cleaner. And then we heard this huge bang upstairs. And the homeowner's like, oh, geez, what was that? And I said, oh, that's probably just your cat. He got scared. And she said, no, I don't have a cat, remember? I said, okay, well, it's probably just a door, because it'll actually open and shut a door if there's enough air going, through from one room to the next. We went upstairs and we looked around and all the doors were still open. I'm sorry. And we went in the bathroom. I was like, oh, geez, look what happened. The mirror in the bathroom was actually sitting in the sink. It didn't break. Not that I'm superstitious or anything, and the reason it fell off is because it was covering a huge hole that went into an attic. Of course, that was when the lady said, oh, well, this was a flipped house. It was built in the 50s. And I'm thinking, yeah, there's probably this ugly medicine cabinet in there. And the flippers ripped it out, threw it in a dumpster. And they were thinking oh, what's the cheapest way to do this? Yeah, honey, just go to Home Depot, get a mirror. I'll put a nail in. We'll just put a mirror over it. No one will ever know. Until I come along and I reverse the flow of the air with the blower door and suck it off the wall, right? So, obviously she said, yeah, that part of the house has huge ice dams. And I'm like, well, that's because that attic is probably the same temperature as your bathroom. You basically have an open window, right into your attic here that you didn't even know about. And this, believe it or not, beautiful house. I think we can all agree. That's Lake Winnipesaukee in the background. Multi-million-dollar house. Driveway was like a half-mile long. I thought I was at the wrong house because this house was in the NHSaves rebate program, which is supposed to be for the most inefficient homes in New Hampshire. I thought I was at the wrong house. I knocked on the door and said, no, this is the right house. Come on in. They got, thousands of dollars from Eversource to help fix this house because it was so bad. They had ice dams so bad that this is one of the houses that had buckets and it was sheetrock falling in, like big clumps of drywall onto their floor because the ice dams were so bad. It was backing it up under the shingles and everything. Just a classic story. So, if your house doesn't look like this, don't feel too bad because, you could have spent a lot of money and bought this house and you still could have a huge ice dam problem and a huge energy bill and all sorts of issues. So don't feel too bad. And with that, I am going to stop sharing and turn it over to Andy for the last section that covers heating and cooling equipment and some of the rebates available to you through New Hampshire Saves, especially the one for existing homes.
Thanks, Ted. And I think a hint there in terms of what the problem was with that house is it was really a huge air leakage problem, right?
Oh, yeah. When I ran the blower door, I actually thought I had made a mistake and I thought I forgot to close a couple of windows. And I went around and looked and I'm like, oh, geez, sure enough, all the windows are shut. But it was still like this astronomical number because it was just a major design flaw in how they built this house. And most of the air was just unobstructedly sneaking up into the attic through a place that you couldn't even see unless you got up on a ladder. Beautiful house. It could have been on a coffee table book of, the finest lakefront homes of New Hampshire. But it's also in my slideshow of like the worst energy performing homes in New Hampshire. So,
and suffice it to say, there's plenty of architects that are really paying attention to sustainability these days, and they're making sure that there's a blower door. If that house would have been tested with a blower door, they would have known there's a huge problem here. But so suffice it to say, not all architect design houses are problematic, and we're certainly moving.
Yeah, I don't see those ones though. They those ones usually aren't calling for an energy audit, but.
So I'm going to talk about that program that Ted mentioned, the Home Performance with Energy Star. I'm first going to talk about a few other rebates and programs and services that the New Hampshire Saves program has. It's really, there's no like New Hampshire Saves office or staff. It's really a group of the 4 utilities that you see there getting together and saying, let's be consistent in our energy efficiency programs. And this is all regulated by the New Hampshire Public Utilities Commission. And it is kind of interesting to think like, well, why do these utilities actually pay us to get rid of an old inefficient refrigerator? Or why do they pay us to, air seal our home? Well, really, they're all about negawatts, just like Ted said at the beginning of the presentation. And really what they're trying to do is incentivize cost-effective, kind of sensible measures that are going to reduce energy consumption. So then they don't have to purchase more natural gas or electricity from the wholesale market. They don't have to have more power plants that are getting built, more transmission lines, things like that. It really makes sense. It's kind of one of those win-win sort of things. Makes sense for them, makes sense for you folks as well. And so there's a variety of different programs that the New Hampshire Saves utilities have altogether, and I'm just going to really briefly talk about a couple of them. We already mentioned, Ted had already mentioned some of the incentives that are available for appliance rebates. And sometimes when you buy lighting, you kind of get built-in incentives to help kind of create a low cost for the LED lights and fixtures and things. And so there's plenty of different rebates and incentives available for heating equipment, as well as air conditioning and domestic hot water. And I'm not really going to cover them all in a great amount of detail, but suffice it to say, there's good rebates if you want to get, say, for example, you have natural gas with Liberty or Unitil, and you want to get a high efficiency boiler or furnace. And I strongly encourage you for all these rebates to go to NHSaves.com to look at the specifics. They vary a little bit by utility, but for the most part, they're pretty consistent across the utilities. Very popular these days are these cold climate heat pumps. Many people call them mini splits. And they're not exactly boiler or furnace replacements. Sometimes you can get it as a furnace replacement, but they're more these heads that go up on walls. And the amazing thing about these heat pumps now is that they really can heat very effectively 0-degree air Even some of them go down to -20 and they're still outputting as much heat as what they're designed for. So, if you think, oh, these heat pumps don't work below 20 degrees, that's really an outmoded thought. And these cold climate heat pumps, the ones that are designed for our climate, are very effective. Also, heat pump electric hot water heaters, same sort of concept. They're, whether, and I'll have a slide coming up, whether we're talking about a refrigerator, a heat pump hot water heater, or a heat pump mini split, they're all kind of working on the same principle of moving heat around. So those heat pump hot water heaters will take some heat from, say, like the basement or other area that they're in. That's great in the summertime. They also help to dehumidify. It is a factor you have to keep in mind in the wintertime. But for the most part, electric hot water heater that's a heat pump style is going to be more cost effective these days than either oil or propane, and certainly a lot more cost effective than the old style resistive electric hot water heaters. A lot of people don't realize this isn't a New Hampshire Saves incentive, but a federal incentive, that there's a 30% tax credit for new energy efficient wood and pellet stoves. And that 30% tax credit includes the installation costs. So if you are considering wood heat, and that is kind of one of the fuels that hasn't gone up in price as much as others, good time to be taking a look at that. Wi-Fi smart thermostats, we talked a little bit about. They are pretty cool. A lot of them have occupancy sensors, so they'll automatically turn down the heat or cooling temperature. And those can be, there's incentives for those associated with other heating. But one thing to kind of keep in mind with all these, particularly like heating systems, sometimes we get a little bit fixated with going after equipment when really it's the building envelope or the building shell that might be more important. So think about, two scenarios. One, you have a really, really efficient heating system in a building envelope that has got a lot of air leaks, a lot of lack of insulation. And then another one is a relatively inefficient heating system, but a really efficient building shell. I can tell you for sure, I would much rather live in the later example, because you could have a pretty cruddy heating system, but if you have a building envelope that keeps that heat in really well in the wintertime, it doesn't matter that much. You could have just baseboard electric heat and it still wouldn't be very expensive. But on the other hand, kind of like a really efficient pump going into that leaky bucket there, that is not a very good system. So it's really important to kind of get that envelope in good shape before getting a new heating system, or at least consider that as kind of the first priority. And the other benefit is that means you don't have to purchase as big a heating system as well. But certainly efficient heating systems are going to help in the bigger scheme of things and something to consider. But even something as simple as sealing and insulating ducts can have a tremendous impact on the total heating costs. So, it's not just the heating equipment, but the rest of the system as well. Even something as simple as the low flow shower heads and aerators or pipe insulation that Ted mentioned, that might be a lot less money and actually more savings than some of the more efficient hot water heaters that are out there. So keep in mind that it's kind of look at the whole system. So as I mentioned, these mini splits, they will extract heat from actually really very cold air. There's some good guides out there that'll tell you exactly how well the different models will work, so you can kind of compare brands and all, but there's multiple brands that all do a very good job these days. And the heat pump hot water heaters, they're about 2 or 3 times more efficient than a regular hot water heater. And it's kind of a weird concept to think a heat pump is extracting heat out of 0-degree air. But just keep in mind that there's a big difference between what we consider 0-degree air and absolute zero. So there's still a lot, kind of from the physics perspective, there's still a lot of heat in 0-degree air. And it's just the heat pump's just concentrating that heat and moving it through the refrigeration cycle into the house. And it's doing just the opposite in the summertime. It's taking the heat from the house and moving it outside, just like a refrigerator does. So just a real quick sampling of different rebates that are available. a ton of heating or cooling with these heat pumps is 12,000 BTUs. You might have a house that needs 4 or 5, maybe 8 tons or something like that. It's not going to be a huge incentive. And it's partly because of that whole concept that a more effective use of New Hampshire Saves incentive dollars would be going for the envelope. And I'll just talk about that in just a minute. Some pretty good incentives depending on the efficiency for replacement natural gas boilers and furnaces, heat pump water heaters, some incentives. And keep in mind that a lot of these things I'm talking about right now, the incentives are coming from the utilities. And then with the Inflation Reduction Act, there'll be some incentives on top of that. So you kind of get a double set of incentives. And you can take a look at those links that I sent in the chat if you're curious about what the incentives are. A lot of those incentives for equipment don't start until 2023, so keep that in mind. And as I mentioned, some of these are utility-specific incentives, so it makes sense to go to that NHSaves.com website. The New Hampshire Saves Energy Star Certified New Homes program, very nifty program. It's kind of aimed at builders, but it's there's both financial incentives as well as kind of technical assistance that's provided by what's called a home energy rating system rater. And they will do like a blower door test. They'll even look at the plans, make sure that everything is functioning well. And so you get a house that has higher resale value because of its efficiency, but it's also much more comfortable as well as having energy savings. And the utilities have also sponsored a drive to net zero competition for home builders because we're moving more and more towards this whole idea of reduce then produce. In other words, make a building, whether it's residential or commercial, as efficient as possible, and then put solar panels on the roof. And we're moving closer and closer to homes and other buildings that are so efficient that those solar panels are enough to provide all the energy needs, heating, cooling, electricity, everything else, domestic hot water over the course of the year. And that would be considered a net zero home. So probably the most important program that New Hampshire Saves has in relation to what we've been talking about is this Home Performance with Energy Star program. It's a national program, and some of the incentives that we have here in New Hampshire are some of the best around. The incentive up to $6,000 per household at a 75% utility cost share level. That's pretty dang impressive. And it includes a comprehensive home energy audit with the sort of things that Ted was talking about. The net cost of that audit is actually zero. You pay $100 up front, but that $100 counts towards your cost share towards any of the 25% cost share towards any of the work that gets done. And a lot of the utilities can help out with low or zero interest financing for the part that you have to pay. So the way that you find out if you're eligible for home performance with Energy Star is on the energy audits and weatherization section of the NHSaves.com website. And so you'll see this green test your home button, and that's what you use. And the information that you need is pretty straightforward. It's 12 months of heating fuel usage, whatever fuels you use, any and all, conditioned square foot of the home, and what type of heating fuel you use, and your utility provider and zip code. And so here's an example. That's what it looks like, the little calculator. So it's a Eversource house in Laconia that's 2,000 square feet, and it uses 800 gallons of heating oil and, 2 full cords of wood per year. And if you are eligible for this program, you're going to have to verify that fuel consumption. So it could even mean if you cut your own wood, it could even mean taking photographs of your wood pile or receipts of fuel deliveries, that sort of thing. And this house, as an Eversource customer, barely qualifies. 9.04 is its home heating index score, and a 9 or above qualifies. So essentially, the utilities are looking for homes that have a quite high energy use for their square footage. So we were joking before the program started that somebody keeps their thermostat down to 60 degrees, Unfortunately, it's great that they're frugal, but it probably means that it's less likely that their home's going to qualify. It's more the energy hogs that are going to qualify, and it's going to be more, there's going to be more relative cost savings and energy savings associated with that home, and that's what they're looking for. And the qualifying number has changed a little bit over the years. It used to be an 8, now it's a 9 for Eversource and New Hampshire Electric Co-op. And if you have Liberty Natural Gas, unfortunately, it's even a higher number. It's a 12, so it's a little bit even harder to qualify. So just keep that in mind, that it might vary a little bit depending on the utility. But let's just say that you do qualify. You can pick a contractor from amongst the list that they have, or you can have them assign a contractor to you. And that contract coordinator is going to conduct an energy audit, and then they'll coordinate, could be the same company or they work with another company to do the installation work. And this is the actual example of work that got done in a house. So they maxed out that $6,000 incentive, but they only had to pay $4,100 and change for the customer contribution. So it was a $10,000 project altogether. And notice also that because utilities recognize that air sealing is so important, they're providing 100% rebate for the air sealing portion of a house. And I would say, these days that dollar savings is probably actually going to be quite a bit higher than that, just because we're paying more for our fuels than we were when this estimate was produced. So there's also a program that's very similar to Home Performance with Energy Star, and it's an income qualified program. So for households that are on like fuel assistance, energy assistance, typically they're going to qualify for this program. It's a low income weatherization assistance program. There's also a utility home energy assistance program, very similar. The work that's done is almost identical to the Home Performance with Energy Star. The insulation, the air sealing, pipe insulation. Sometimes there can be replacements of inefficient heating systems. That's a little different than Home Performance with Energy Star. And the big difference is that it's completely free to the renters or the homeowners in the program. So easy way to find about that is dialing 211. Southern New Hampshire Services would be the local community action agency in the Derry area. So we're pretty much at the end here. It is around an hour and a half after we started. Liz, I don't know if we want to kind of open things up for questions. We do have both Ted and my email addresses here. I do energy training and program management work at Lakes Region Community College. I wish I could say for small businesses in Derry that our New Hampshire Rural Renewables Program would be relevant for you folks, but it's for the rural part of the state. But if you know anybody that's in, say, Concord, Portsmouth, Keene, and Northwood, including those towns, we can provide no-cost technical assistance to small businesses for energy efficiency, solar, wood heat, anything else like that. And that's a program that's funded by USDA Rural Development. And there was some interest in commercial energy efficiency as well. So I'll be glad to take, and Ted as well, take questions about that. And I'm gonna stop sharing my screen and we can go back to other slides or show you more about the Inflation Reduction Act or just call it a night.
All right. There is a question in the chat. It says, if you only qualify for a visual audit, does someone still come to your house?
Yeah, so we don't mention specifically visual audit, and thanks for that question, because it's a program primarily with Liberty.
Yeah, I think they're getting rid of that program too, Andy. From what I heard, that's going away. I put an answer into the chat. I don't know if it came up yet, but yeah, with the visual audit, somebody will come to your house, but really all you get is a Nest thermostat if it'll actually work with your boiler or your furnace, which is not a guarantee. You'll get some free LED bulbs and you get some pipe wrap. So there's really not a whole lot.
That's only for Liberty natural gas customers, and it sounds like maybe even they might
Yeah,
not
I
be.
think they're pulling that back.
All right, Craig put some information into the chat as well. Does anyone have any questions? You can unmute your mics and ask questions as well.
It didn't come up yet, but I just wanted to mention, with New Hampshire Saves, some people ask, will it work if you rent your house? Yeah, it can work. Actually, the program is run based off the electric meter. So there are some homes, like there might be 3 apartments in a house, or maybe even 4. You could actually, the landlord can get 4 rebates to get that house weatherized, insulated and air sealed up. It would go through the electric meter, whoever's name is on the electric meter. But obviously, like, the tenants aren't going to be the one paying for it. It would be the person that owns the property. But it definitely is possible to do, duplexes, triplexes, et cetera. Once you start getting much more than that, it gets into like a multifamily situation. But you can do it if you're a renter. Like I said, it goes by your electric meter, and I know Andy had mentioned that there are some specific commercial rebates available. If you have a lot of small businesses in New Hampshire are just existing in a regular looking house, and it still even has a residential electric meter. So if it does, you could even get into the New Hampshire the home performance program. It's designed for homes and residences that people live in. But if your electric meter is, if I understand it correctly, this has happened before, if as long as the electric meter is a residential meter, which for a lot of businesses it is, you can still get the building shell improved through that program.
And there was a question about just restating what the tax credit amount is for wood stove, pellet stove installations. It is 30%, 30. And that includes the cost of the wood stove plus the cost of the qualified installation. It's only for wood stoves that meet this EPA 2020 efficiency and lower pollution levels. But those are the really good stoves that are out there that are measured for their efficiency. And those, I would recommend getting those stoves anyway. But yeah, it's a nice incentive if you're considering a wood or pellet stove.
All right. There is a question in the chat. What is the average cost of an audit with the blower door?
I was just typing an answer to that one too, but we can cover that out loud. I would say $300 to $500 is sort of the average price for that. Some contractors will credit that back to you, subtract it off the cost of the work that you might get done coming out of that. But that's kind of just a ballpark figure.
Right. Yep, that question answers in the chat. Does anyone have any other questions?
It's great that you folks have a net zero committee. I think that is really awesome.
I feel like I should be playing the Final Jeopardy music for questions. Like, all right, anybody?
Yeah.
I just want to point out, Craig had mentioned there's a Resilient Buildings Group, which can provide kind of technical assistance for small businesses. It does vary a little bit depending on what utility you're working with. So they work with Unitil and Liberty Utility business customers. And then there's folks who work directly at Eversource if you're interested in assistance from them on kind of the electric saving side with small business. And New Hampshire Electric Co-op, not as relevant for you folks, also has staff that directly help. But there's some good presentations out there. I'd be glad to send one that I have about the different commercial energy efficiency programs that are out there with New Hampshire Saves.
We're getting a couple of thank yous in the chat. If there aren't any more questions, I was about to say, Ted and Andy, you guys did put your contact info out there. And if you didn't get it, you can always email me and I'll type this into the chat and I could pass the information along if I need to. So you can always email me if you didn't get the information and I can contact Ted and Andy as well. Or Ted and Andy, would it be okay if I gave them your email addresses? Because I could do that too.
Yeah, that's fine.
Okay.
Sure.
All right. But yeah, if we don't have any more questions, then I think we could wrap it up for the night. Thank you everybody for coming, and I hope we can see you at some of our upcoming programs in October, especially the Opera House ones. Actually, keep your eye out on the Derry Library's Facebook page, because there is going to be a video advertising the Phantom of the Opera program coming out soon. So, and also someone might have made an appearance in it. I won't say who. All right, but if that is the case, then I will let everyone get on to their
All right.
night. And
Thank you for coming, everybody.
yeah,
Hope you got
very
something
much
out
for
of it.
coming.
Yes, thank
Good
you,
luck.
Liz.
Good luck
Appreciate it.
this winter.
Absolutely.